Hello everyone, this is our fourth video under the GCSE topic revision called Linear and Quadratic Sequences. First, look at the theory behind this section. Arithmetic sequences, sometimes called as linear sequences. Sequence of numbers such that the difference between the consecutive terms is constant. For an example, if we consider a sequence called 6, 9, 12, 15, 18 and 21, if you consider the difference between 9 and 6 is 3, 12 and 9 is 3, 15 and 12 is 3. So any two consecutive numbers, the difference are same. So find out the first term is the first number of the sequence is 6 and the difference is 3. How to find the nth term of a linear sequence is nth term is equal to difference times n plus first term take away the difference. So in this example, the difference is 3. So 3 times n, which is 3n, and the first term is 6 and the difference is 3. So 6 take away 3 is 3. So 3n plus 3 is the nth term. Let's look at example 2. 16, 14, 12, 10. So when you see this sequence, the difference between two terms is not 2. It's minus 2 because second term is 14. Take away the first term. So 14 take away 16 is minus 2. So throughout the sequence, that minus 2 remains as a constant. So first term is 16. Difference is minus 2. So if you write the nth term, so nth term equal minus 2, which is the difference, times n plus first term 16 minus and minus 2. So minus times minus is plus. The answer is minus 2n plus 18. Geometric sequences. Sequence of numbers where each term after the first is found by multiplying the previous one by a fixed non-zero number called the common ratio. For an example, have a look at the sequence 2, 6, 18, 54 and 162. So each term, the first term is multiplied by 3, which gives 6, which is the second term. Second term again multiplied by 3 is 18, 18 multiplied by 3, 54, and this continues. So the first term is 2, common ratio is second term divided by the first term. So 6 divided by 2 is 3. There's an equation you can follow. Nth term equals first term times common ratio to the power n minus 1. For this example, first term is 2 times common ratio is 3 to the power n minus 1. So this is the nth term of the geometric sequences. Quadratic sequences. A quadratic sequence is a sequence for which the nth term is an squared plus bn plus c. The constants b and c might be 0, but a it's not a 0 constant. If you consider the an squared plus bn plus c is a quadratic sequence, if you consider the sequence running from first term a plus b plus c and 4a plus 2b plus c and is continuing there like that, the first difference is second term take away first term. So 4a take away a is 3a, 2b take away b is b, c take away c is there's no c. So likewise you can taking away from the two consecutive terms and you can find the common difference. Then the second difference need to be found because the first difference are not equal. So the second difference is 5a plus b take away 3a plus b, you end up with 2a. So again the 2a is going to be constant throughout the sequence. So the important terms are first term, the first difference and the second difference. If you consider an example, 6, 17, 34 and 57 is a sequence. So they are asking for a find the nth term. So all what you want to do is find the first difference, which is 17 take away 6 is 11, 34 take away 17 is 17, 57 take away 34 is 23. Find the second difference, 17 take away 11 is 6, 23 take away 17 is 6. So the important terms are, start with a 2a, which is the second difference. So 2a equals 6. So a equals 3. Then the first difference is 3a plus b equal 11. So substitute the 3. 3 times 3 is 9. 9 plus b equal 11. So b equal 11, take away 9 is 2. Then the first term is a plus b plus c equals 6. So a equal 3, b equal 2, c equal, we are going to find, which is 6 minus 5 is 1. So we found all the constants. If you substitute in the equation, the expression there, so an squared plus bn plus c, so 3n squared plus 2n plus 1. We have studied the theory behind the topic linear and quadratic sequences. Let's look at some exam style questions. You can download the tutorial from our website at www.smart-tutors.co.uk/worksheet.php. Under the E11 category, you can download the tutorials. Question number 1. The nth term of a sequence is n squared plus 4. Alex saying the nth term of a sequence is always a prime number when n is an odd number. Alex is wrong. Give an example to show that Alex is wrong. So they only asking for an example and it's a 2 marks question. So we need to find out, let's do some working. So when n equals 5, so n squared, so 5 squared plus 4 is 29. I think 29, yes, 29 is a prime number and n is an odd number. So if I use, let's say n equal 8, is 8 is not an odd number, so right, n equal 9, so 9 squared plus 4, so 81 plus 4 is 85, is not a prime. So we found the answer. So we are going to write here, when n equal 9, so n squared plus 4 is 81 plus 4, which is 85. So 85 is not a prime number, not a prime number. That is the answer for the first question. Second question, here are the first 4 terms of a quadratic sequence, 7, 18, 33, 52. Find an expression in the terms of n for the nth term of the sequence. So 7, 18, 33, 52. So first difference is 11 and 15 and 19, and the second difference is 4 and 4. So we already have some formulas for this one. So the second difference is 2a. So the first difference is 3a plus b, and first term is a plus b plus c. So start with the 2a. So 2a equal 4. So a equal 2. So 3a plus b equal 11. When you substitute a equal 2, 6 plus b, so b equal 5. And the last one, a plus b plus c equal 7. A equal 2, b equal 5 and c equal 7. So c equal 0. So you got the answers are a equal 2, b equal 5 and c equal 0. So the general format of the equation is an squared plus bn plus c. You substitute the answers, so 2n squared plus 5n. That is the answer for the question number 2. Question number 3. Here are the first 4 terms of an arithmetic sequence. Find in terms of an expression for the nth term of the sequence. So nth term, so first of all we need to find out the difference between the first and second term, which is plus 7, and second and third term also plus 7, and it's increasing by plus 7 all the time. So the nth term is 7n plus first term is 3 minus the difference. So which is 3 take away 7 is minus 4. So the answer is 7n minus 4. So that is the answer for the first part, 2 marks question. Second part is 150 term of this sequence. So all what you want to do is 7n minus 4 equate that to 150. So 7n equal to 150 plus 4, which is 154, and I'm going to divide both sides by 7, so which is n equal 154 divide by 7, 22. So 22nd term is 150. So if this n answer sometimes comes as a decimal or fraction, you can say n is not an integer, then 150 or whatever the number cannot be in the sequence. But in this case, n is a whole number, 22 is a whole number, so it is possible. So 22nd term is 150. Question number 4. The nth term of a quadratic sequence is n squared plus 3n minus 2. Find the fourth term. They are not asking 4 terms, fourth term. So all what you want to do is substitute n equal 4. So n squared plus 3n minus 2. So 4 squared plus 3 times 4 minus 2. The answer is 16 plus 12 minus 2. So 28 minus 2. So the answer is 26. Question number 4. Here are the first 5 terms of a different quadratic sequence 1, 7, 17, 31, 49. Find the nth term. So all what you want to do is 1, 7, 17, 31. So first difference is 6, 10 and 14, and the second difference is 4 and again 4. So this one is going to be 2a and this one is going to be 3a plus b, and the first term is a plus b plus c. So work out all the values of a, b, c. So 2a equal 4, so a equal 2, 3a plus b equal 6, and 6 plus b equals 6. So b equals 0, and a plus b plus c given 1. So a equal 2, b equals 0, and c equal 1. So if you work out that one, c equal minus 1. So we have found the a answer, which is 2, b answer is 0, and c answer is minus 1. So the final answer is a n squared b n is the general format of the quadratic sequence nth term. So substituting that one is 2n squared, b is 0, minus 1. So if we can substitute n equal 1, 1 squared is 1, 1 times 2 is 2, take away 1 is first term is coming, 2 times 2 is 4, 4 times 2 is 8, take away 1 is 7 also coming. So the answer is correct. So 2n squared minus 1. Question number 5. Here are the first 4 terms of an arithmetic sequence. Find the nth term. So 8 and 11 is 3, 11 and 14 3, 14 and 17 is 3. So the answer is 3n plus first term take away the difference. So 3n plus 5 is the answer, and there's a b part there. Find the 100th term of this sequence. So when n equal 100, the nth term 3n plus 5, all what you want to do is substitution. 3 times 100 plus 5. So the answer is 305. 305 is the final answer for the question number 5. Question number 6. The first 3 terms of a different Fibonacci sequence are A, B, A plus B. Show that the 6th term of the sequence is 3A plus 5B. So if you can see the sequence, this is not an arithmetic sequence or quadratic sequence. There is a pattern of adding the A with B is A plus B. So if you want the 4th term, so the 2nd term and the 3rd term need to be added together, so which is A plus 2B. And if you want the 5th term, 1, 2, 3, 4, 5th term is A plus 2B plus A plus 2B plus A plus B. So which is 2A plus 3B. So write it here, 3B. Now is the 5th term is 2A plus 3B plus A plus 2B, which is 3A plus 5B. So 3A plus 5B. So if you can put, this is the 1st term, 2nd term, 3rd term, 4th term, 5th term and 6th term. So we already proved 5th term is 3A plus 5B. Given that the 3rd term is 7 and the 6th term is 29. So 3rd term is 7. So 3rd term is 7 means A plus B is 7, because 3rd term we can see the A plus B is the 3rd term. They have given the numeric value which is 7. That is my first equation. 6th term, which we found now, 3A plus 5B equal 29. So this is my second equation. So 3-mark question. You need to do a little bit of steps to how you are finding the A and B. This is simultaneous equation. I'm going to times the first one by 3. So first equation by 3 to make the coefficients same. 3A, 3B equal 21. 3A plus 5B equal 29. So take away, this is, let's say this is my third equation and this is my second equation. So second equation, take away the third equation. These two cancelled. 5B take away 3B is 2B equal 8. So B equal 4. So when you find out the B equal 4, A equal 3. So find the value of A and B. So A equal 3, comma B equal 4. Question number 7. The nth term of the sequence is given by an squared plus bn. A and B are integer values. The second term of the sequence, second term means n equal 2. So n equal 2 means A times 2 squared plus B times 2 equal minus 2. So 4A plus 2B equal minus 2. So if I divide everything by 2, 2A plus B equal minus 1. So this is a simplified version of the first equation. I hope we can find another equation to solve A and B. So the second data is given fourth term of the sequence. So fourth term of sequence mean n equal 4. So if you can substitute n value is 4. So A times 16. So 16A plus 4B equal 12. So this is my second equation. So if I write 2A plus B equal minus 1 underneath the second equation, I'm going to times the first equation by 4, which is 8A plus 4B equal minus 1. So I'm going to be taking away from first equation the second equation here, this one, take away the one multiplied one. So 16a take away 8a, which is 8a, equal 12 take away minus 1. We didn't multiply this one, so 4 times minus 1 is minus 4. So 8a equal 12 take away minus 4. So 12 take away minus 4. So 12 plus 4, so which is 8a equals 16. So a equal 2. So if you find a equal 2, you can substitute in the first equation 4 plus b equal minus 1. So b equal minus 5. So the a value and b value we found. Question number 8. Here are the first 5 terms of a quadratic sequence. Find an expression for the nth term. So let's start with our steps 0, 2, 6, 12 and 20. So the difference is 2 here, here 4, here 6, here 8. So the second difference is 2, 2, 2. So we know the method. We are going to equate this one to 2a, and we are going to equate this one to 3a plus b, and we are going to equate the first term to a plus b plus c. So let's start with the working from backwards. So 2a equal 2, a equal 1, a equal 1 means so 3a plus b equal 2, a equal 1 means so 3 plus b equal 2, so b equal minus 1, and a plus b plus c equals 0. So a equal 1 minus 1 plus c equals 0. So 1 and minus 1 cancels, so c equal 0. So the general equation is an squared plus bn plus c. If you substitute all the values you found, so 1n squared, so n squared, b value is minus 1, so minus n, c value is 0. So the answer is n squared minus n. The second question, question number 9. Here are the first 5 terms given, find the nth term. So pretty much same as the question number 8. Let's start with our steps 4, 11, 22, 37. That's more than enough. So difference is 7, difference is 11, and here the difference is 15. So the difference is here 4 and here 4. So let's start with our work. 2a equal 4, so a equal 2, 3a plus b equal 7, 6 plus b equal 7, b equal 1, a plus b plus c equal 4. So a equal 2, b equal 1 and c equal, we are going to find. So c equal 4 take away 3 is 1. So the answer is an squared. So a equal 2, so 2n squared, b and b equal 1, so 1n plus 1. So that is the final answer for question number 9. Question number 10. The first 3 terms of an arithmetic sequence are 2x, x plus 4, 2x minus 7 respectively. Find the value of x. So let's start this one. So 2x is the first term, x plus 4 is the second term, and 2x minus 7 is the third term. So they have given a clue, arithmetic sequence. Arithmetic sequence definition says difference between 2 terms has to be equal. So if we find out the difference between second and first term, x plus 4 minus 2x, which is minus x plus 4. So that is the difference between the second and first terms. Now we find the third and second terms, which is 2x minus 7 take away x plus 4. We are going to do 2x minus 7 minus x minus 4. So 2x take away x is x minus 11. So the difference has to be equal. So minus x plus 4 equal x minus 11. So if you take the minus x the other side, so plus x together with x, 2x minus 11 this side is 15. So x equal 7.5. 15 divided by 2 is x equal 7.5. So if you substitute to the x value, so 2x is 15 and x plus 4 is 11.5 and 2x minus 4 is 2x is 15 minus 4 is 8. So here if you see the difference is what is the difference here? Minus 3.5 and minus 3.5. So that obeys the arithmetic sequence. So the answer x value is 7.5. So the calculation here I did to check whether arithmetic sequence works or not. So it is working. So the answer value is x equals 7.5. The next part, the first three terms of another sequence are also 2x, x plus 4, 2x minus 7 respectively. Verify that when x equal 8, the terms form a geometric sequence. So we know the definition of geometric sequence. Let's find the sequence by substituting x equal 8. When x equal 8, so 2x is 16, comma, x plus 4 is 12 and 2x minus 7 is 16 take away 7 is 9. So this is the sequence. If it is a geometric sequence, the ratio between two terms are going to be same. So second terms, I'm going to put a ratio is R1. Here the ratio is R2. So let's find out the R1. R1 is 12 divided by 16. Careful here. Second term divided by the first term, not other way around. So second term 12 divided by 16 is 3 upon 4. R2 is third term 9 divided by 12. So if I simplify this one, I get 3 upon 4. So common ratio between terms are equal. Therefore, the sequence is geometric sequence. Question number 11. The first three terms of an arithmetic sequence are 8 plus root 2, 10 plus 5 root 2, 12 plus 9 root 2 respectively. Show that the nth term of the sequence is given by a expression. They have asked you to show. So this type of the question we are predicting to the next year. They might include the surds inside a quadratic or linear sequence. Let's start with this sequence. This is the arithmetic sequence. So arithmetic sequence means we need to find the a, which is 8 plus root 2. Difference is the d. Second term 5 plus 10 plus 5 root 2. Take away 8 plus root 2. So if I take away, so 10 plus 5 root 2 minus 8 minus root 2. So 10 take away 8 is 2. 5 root 2 take away root 2 is 4 root 2. So how to find out the nth term? So nth term nth term of an arithmetic sequence, we found is first write the difference. So the difference is 2 plus 4 root 2 times n plus first term 8 plus root 2 take away the difference. So the difference is 2 plus 4 root 2. So if you simplify this, third is 2n plus 4 root 2 n plus 8 plus root 2 minus 2 minus 4 root 2. So here if I simplify, 8 take away 2 is 6. So 2n plus 4 root 2 n plus 6, then root 2 minus 4 root 2 is minus 3 root 2. Now the question is 2n plus 6 already came up, so 2n plus 6 I can separate them. Then root 2, if I take the root 2 out, here 4n minus 3. So that is the answer they are asking. B part, find the 12th term in the a plus b root 2 format where a and b are integers need to be found. So when n equal 12, so 12th term is n equal 12. So 2n means 2 times 12, 24, plus 6 plus root 2, 4 times 12 minus 3. So if you simplify, 24 plus 6 is 30 plus root 2 times 48. 48 take away 3 is 45. So the answer is 30 plus 45 root 2. So this is in the format of a plus b root 2. So a equal 30, b equal 45. That is the end of the tutorial session. I hope you do like the video. If you do like the video, please subscribe to our channel to see all the upcoming videos. If you want to download the tutorial we discussed in this topic, you can download it from our website www.smart-tutors.co.uk/worksheet.php. Thank you.